spreadsheet like Excel, file type of thing. Then I imported it to a computer. Then started analyzing. The one thing I want to point out, maybe it's not that important, but I want to point out because I just want to, is this, variable is what we call a categorical variable. So it has front, back, front. Computer doesn't know. Like if you, tell computer, okay, analyze this. Computer doesn't know what this means. Front. To them, front doesn't mean anything. Back doesn't mean it. You have to tell them what it means. What I usually do is to convert this variable into a numerical variable, like 0, 1 variable. So I would give 1 to those who are sitting in the front, 0 to those who are sitting in the back, and so on. And then the computer knows, like computer can understand 0 and 1. It's very easy to see. None, like 0 means no, 1 means yes, something like that. And computer can understand that. So that's the type of operations we have to go through when you start analyzing data. Is that good enough?
That's a great answer.
Okay, so with this type of data set, what we usually do is first do really, really simple analysis. The most obvious way is to first, so I have the data, 30 students, and the most obvious way is to divide it into two groups. One for those who are sitting in the back, the other one for those who are sitting, those who are sitting in the back, and one for those who are sitting in front. So that's the first step. Then we can calculate the average grade for each group, right? So for those who are sitting in the front, 3.49 was the average, so the mean grade. For those who are sitting in the back, 2.86. So what that means is, if I want to guess a grade for those sitting in the front rows, something like that, I could say your grade is probably 3.49. For those you guys, it's probably 2.86. And I'll be closest. I'll be pretty good. That's the best guess actually, because it's the average, which is the mean. And that's what I would do. So that's what this tells us. Then we can calculate the difference, which is 0.63. 0.63.
Well, the thing that I'm wondering though is, so we just have 30 people, and we see a number that's 0.63, but if we would kind of even round those, both of those numbers would maybe be rounded to 3. So is 0.63, is it big enough of a difference to then understand, or?
So that's a great question. On one hand, 0.63 seems big enough, right? That difference seems big enough. It's the difference between like B minus and B plus or something like that, or B and A minus. That seems to me pretty big. However, as Chris pointed out, it could be just that. It could be just about this particular sample. It may be just, I got this 0.63 because of this introductory biology class, right? If I start collecting data from introductory political science class, maybe I get different numbers. So to what extent can I be confident that this 0.63 actually exists in the real world, which means outside of this particular classroom? So that's a deep fundamental question. I know 0.63 exists in a particular context, but can we generalize it? So I use this word, generalizability. Can we generalize this finding to something, to a bigger context? Statistics is actually a very powerful tool to quantify this confidence. And through, you're going to learn this when you take quantitative methods course. through something called like resampling and bootstrapping and a lot of such statistical methods, we can actually quantify the certainty and confidence we can have about these numbers. And after doing that, we can make graphs like this one. So on the x-axis, I have the C location. So this is for those who are sitting in the front, for those who are sitting in the back, and I have the expected grade for those students. As you know, in a particular biology class, 3.49 was the average grade, right? But then you see this bar around it. What is that? It represents how confident I can be about that number. There are technical interpretation of this particular, these bars, but I'm not going to go through that. All I want you to know is we can actually, using statistics, we can actually quantify, we can actually put these bars and tell you how confident I can be about the true effect or true mean, a true expected grade for those who are sitting in the front. Similarly, I can say that around this, in this area, I can say that the true mean for those who are sitting in the back exists.
So then,
in this area.
if we look at this range, what you're saying is people in the back, the actual average, if you look at all classrooms, could be as low as 275 or as high as 3, a little bit above 3. And then the others is that similar range of what could it could be if we started calculating for every room.
Yeah.
Interesting.
So I can be pretty confident based on this evidence that the difference exists, right? Because there's pretty clear difference. If they overlap, like if the bar was like this high for those who are sitting in the back, then I won't be pretty confident. But in this case, I'm actually pretty confident that there is a relationship between the seat location and the grades students get in the class, and we can generalize it.
So then,
this class, for example.
So then, if we just ask the students right now, maybe in order to be more fair to everyone, if we had assigned seats and then moved everyone every class, so then you think that their grades would average out? Or as I'm looking at this, I see that you've established that there's a relationship